Okay, so in this problem, we are given that propane is burned completely with excess oxygen, and we have the product gas composition, and we are asked to calculate the percent excess O2 fed to the furnace. And we're using atomic species method to do this. All right, so first we're gonna start with our flow chart. So we're gonna have two inlets. So our first inlet is going to be propane. And then our second is going to be oxygen. And before I go on, actually, let me write out our reactions. So we have propane plus oxygen produces 3 moles of CO2 plus 4 moles of H2O. And then in a side reaction that occurs, we have propane plus 7/2 oxygen produces 3 moles of CO plus 4 moles of H2O. And I forgot to balance the oxygen up here. It's 5 moles of O2. I know y'all have probably done balancing of reactions in general chemistry, but if you want me to go through some videos practicing balancing reactions and writing reactions, leave a comment on here and I can prepare some videos for next week going over writing out reactions and balancing those. But for now, let's assume y'all can do that. And then we have our outlet stream N3 with a composition of 0.248 CO2, 0.0612 CO, 0.408 H2O, and 0.286 of O2. Now we're going to do our degree of freedom analysis using the atomic species method. So we have 3 unknowns, which are N1 through N3, and we have 2 species. And those species are oxygen and carbon. Are they? Yeah. So we can take a balance, or we have 1 degree of freedom. So we're gonna take a basis of 100 moles propane. So 100 for N1. All right, so let's start off with an O2 balance. Or actually, oxygen balance, not O2. So we have 2 N2 is equal to N3 times 2 times 0.248, since we have 2 oxygens in CO2, plus 0.0612 plus 0.408 plus 2 times 0.286. And when we multiply all this out, we get that 2 N2 is equal to 1.5372 N3. So divide both sides by 2, we get that N2 is equal to 0.7686 N3. Now we're going to do a carbon balance, and we can plug in this term for N2 in our carbon balance. And we'll be able to solve for N3 and N2. So for carbon, 3N1 is equal to N3 times 0.248 plus 0.0612. Oh, that's it. And from that, we get, so we know N1 is equal to 100. So then we end up getting that N3, or sorry, 300 is equal to .0, not 0.0, 0.31015 N3. That's just this term. And we can get from that N3 is equal to 970.25 moles. And then when we plug that in up here, we end up getting that N2 is equal to 745.73 moles. So to calculate the percentage excess of O2 fed to the furnace, we need to first start with calculating the theoretical oxygen required. And the theoretical oxygen required is going to be, so we have 100 moles of C3H8 propane and 5 moles of O2 react per mole of propane. So theoretically, we need 500 moles of O2. So then the percent excess is going to be O2 fed minus O2 theoretical over O2 theoretical. And that is going to end up being O2 fed is N2 745.73 minus 500. Actually, let me check my formula on this. Yeah, theoretical over 500 times 100. So that is going to end up being 49.1% excess.